The universe keeps making things that should not be there. Planets orbiting dead stars. Galaxies missing the dark matter they were supposed to need. Black holes appearing too massive, too early, and in places where they should not form. None of this means physics is broken. It means our story of the universe is incomplete. These are 10 things in the universe that shouldn't exist, but do. Number 10. The planets around pulsar B257 plus 12. The first confirmed planets beyond our solar system were not discovered around a star like the Sun. They were found orbiting a pulsar, the rapidly spinning remains of a massive star that exploded. A supernova should devastate nearby worlds. Yet at least 3 planets orbit pulsar B1257 plus 12. They may have survived at greater distances, or they may have formed later from a disk of debris left after the explosion. Either way, these are planets circling the radioactive corpse of a dead star. Number 9. WD-1856b. WD-1856b is a giant planet orbiting extremely close to a white dwarf, the compressed remnant of a sun-like star. But before becoming a white dwarf, the star expanded into a red giant that should have swallowed anything at the planet's present location. Recent observations support the idea that WD-1856b survived farther away, then migrated inward billions of years after the star died. It did not endure inside the fire. It arrived after the funeral. Number 8. Tabby's star. Tabby's star repeatedly loses enormous amounts of light in deep, irregular dips, sometimes approaching 20%. A normal transiting planet produces a small and predictable signal. These dimming events are neither small nor predictable. Alien megastructures once entered public speculation, but observations strongly favor uneven clouds of dust and debris. The mystery has become less exotic, but not completely simple. Astronomers know that dust is blocking the star. They still do not have a complete map of the structure producing every strange dip. Number 7. D9 near Sagittarius A star. Near the Milky Way's central supermassive black hole, gravity can destabilize delicate stellar systems and tear gas clouds apart. Yet astronomers discovered D9, the first known binary star system found close to Sagittarius A star. The pair is only a few million years old and appears to have formed in this extreme environment. It will probably merge into one star within roughly 1 million years. D9 is not permanent, but its brief survival proves that even near a supermassive black hole, the universe can assemble something fragile before gravity destroys it. Number 6. NGC 152-DF2. Galaxies are normally embedded within enormous halos of dark matter. That invisible mass provides much of the gravity associated with their formation and motion. NGC 1052-DF2 appears to contain only a tiny fraction of the dark matter astronomers expected. Its existence does not disprove dark matter. In fact, the separation between ordinary matter and dark matter may support the idea that they are different substances. But it creates a new problem. How did a galaxy this large form or survive after becoming separated from most of its invisible mass? Number 5. GW1D0521. In 2019, gravitational wave observatories detected 2 black holes colliding. One had about 85 times the mass of the Sun. That placed it inside a predicted mass gap where dying stars should struggle to produce black holes. Under many models, a star in the relevant range becomes unstable, loses enormous amounts of material, or destroys itself completely. The black hole may therefore have been a second-generation object formed in an earlier merger. An ordinary star may not have been capable of producing it. Another black hole had to do the job. Number 4. El Gordo. El Gordo is a colossal cluster containing hundreds of galaxies, vast clouds of hot gas and an enormous concentration of dark matter. We see it as it existed when the universe was about 6.2 billion years old. Massive clusters are expected to grow gradually as smaller structures merge. Yet, El Gordo was already extraordinarily massive at that stage of cosmic history. It is not forbidden by modern cosmology, but it is rare enough to test how quickly the universe could assemble its largest structures. The cosmos was still young. El Gordo was already a metropolis. Number 3. J0529-4351. This quasar is one of the most luminous objects ever observed. Early measurements suggested that its black hole held 17 billion solar masses and consumed more than a sun's worth of material each day. Better observations later produced a reversal. Astronomers found gas blasting outward at up to 10,000 kilometers per second and revised the black hole's mass downward to around 1 billion suns. The object remains extreme, but the real lesson is more unsettling. The assumptions used to weigh distant black holes can fail dramatically. J0529-4351 was not impossible. Our first interpretation of it was. Number 2. MOM-Z14. The James Webb Space Telescope observed MOM-Z14 as it existed only about 280 million years after the Big Bang. In that short interval, gas had to collapse, stars had to ignite, heavier elements had to form, and a visible galaxy had to emerge from the cosmic darkness. MOM-Z14 is not only surprisingly bright, it also shows unusual nitrogen enrichment that is difficult to produce through normal generations of stars in so little time. Webb is now finding far more bright early galaxies than pre-launch models predicted. MOM-Z14 does not overturn the Big Bang. It tells us that the first galaxies may have formed with an efficiency and chemistry our models did not anticipate. Number 1. QSO-1. QSO-1 existed about 700 million years after the Big Bang. It is only around 1,300 light-years across, yet most of its mass is concentrated in a black hole, roughly 50 million times the mass of the Sun. The surrounding material contains almost no heavy elements, suggesting that very few generations of stars existed there before the black hole formed. This reverses the familiar story. We normally picture galaxies producing massive stars, those stars collapsing into small black holes, and the black holes growing through feeding and mergers. QSO-1 suggests that at least some enormous black holes were born before substantial galaxies surrounded them. It may have begun as a heavy seed created by the direct collapse of a giant gas cloud. More speculative models even consider primordial origins. Whatever the explanation, the black hole appears to have arrived before its galaxy was ready, and may now be helping build that galaxy around itself. None of these objects proves that the laws of physics are wrong. They prove that nature is under no obligation to follow the simplest version of the story we created for it. When theory and the sky disagree, the sky always wins. Which of these objects feels the most impossible to you? Comment below. And if you want to see more cosmic theories, strange objects, and questions science still has not fully answered, watch the next Cosmic Theory Lab video on screen.